Hello everyone. I was just realizing when I made my last video, example 2 of calculating torque, it took over 35 minutes, so it's kind of long and uh, quite detailed, but it was good. I mean, it's the kind of thing that you guys need to see. But at the same time, I wanted to show you an easier method that's a little quicker, and hopefully I can make a shorter video with it. This one just requires us to understand the right-hand rule, and the right-hand rule is basically one of the versions of it is that uh, this would be the x-axis, this would be the y-axis, and then this would be the z-axis for a right-handed coordinate system. Or if you're actually taking a cross product, this would be the first vector, the second vector, which is 0 if it's parallel, or 0 if it's anti-parallel, but anywhere in between is acceptable. So that'd be this first vector crossed with the second vector gives you the third vector. Again, got to use your right hand on all those. So let's give this a try. I'm going to show you how to do the exact same vectors we just did, only I've already worked them out in detail, and we're going to calculate a cross product with them. So let me give you access to my iPad screen. All right, so you can see, especially if you've already done example 2 that I recorded earlier, this is now example 3, but you can see it's the exact same problem, only I've taken the time to go ahead and give the people the r vector, which is the lever arm vector, and the f vector, which is a force vector, already worked out in detail. So let's begin. Solution. Work is r cross f, excuse me. I wrote cross instead of equals r cross f. Now, the method I'm going to use here is something that requires the fact that the cross product is what we call a linear operator, that it can act on a linear combination of vectors in such a way that you can just sort of pull the constants out in front and just let the vectors act on the vectors. So that's what I'm going to do. I'm going to say torque is equal to r cross F, and instead of R, I'm going to write 1.00. I'm going to leave the units off here for obvious reasons. Plus 4.00. I might even drop some of the sig figs as well. Now that's just writing out an R value as a vector. Now I'm going to write out the F value as a vector, 9.63 I hat plus 48.1. Actually, that was supposed to be a negative. Sorry about that. That is an actual typo, everybody. That's supposed to be a negative. So, or handwritten no, whatever you call it. So I'm going to do like this. Let's say the y component and the z component are both negatives, so it should be minus 48.1 newtons, or excuse me, without the units. 48.1 j hat, and then minus 9.63 k hat. So sorry about those typos. I will fix those before I submit this document. Oops, I can do it right now. Do that right now as well. All right. So there's our actual vectors. 9.63 newtons I hat minus 48.1 newtons J hat minus 9.63 newtons K hat is the R, or excuse me, is the force vector. Now what we do is do the distributive property. So if I first consider taking first term and first term, using the linearity of it, I get one. Oops, I'll stick to the green. Sorry about that. I get 1 times 9.63, and then it's I hat cross I hat. Now I do the next one, which is plus 1 times negative 48.1, and then it's I hat cross j hat. Notice I'm not changing the orders of the cross product. That would be a real bad problem. It would make an erroneous result. So don't do that. Now I'm going to take and let the first term hit the third term. And when that happens, we're going to get 1 times negative 9.63. And again, it is I hat cross K hat. Like that. I never put the K hat on there. So that's just the first term. Now I'm going to do the second term in R and let it hit each of them. So this will be 2 times 9.63 times I hat, or excuse me, J hat, because the 2 is the J hat term. So it'll be J hat cross with I hat. Now I'm going to let the 2 hit the negative 48.1. So we'll say 2 negative 48.1. And then, of course, that's J hat. I hate it when this thing turns to an eraser. And that's J hat cross J hat. And now I'm going to let the 2 hit the negative 9.63. So that's 2 times negative 9.63 times J hat cross K hat. Now I've got to deal with the third term in R, and that's the 4. So this time it's going to be 4 times 9.63. And of course, that one is K hat cross I hat plus 4 times negative 48.1 times J hat, or excuse me, times K hat cross J hat. And then finally 4 times negative 9.63. So 4 negative 9.63. And of course, that's K hat cross with K hat. Now, remember, there's also the rule about the magnitudes of cross products, specifically A cross B magnitude is equal to the magnitude of A times the magnitude of B times the cosine, or excuse me, times the sine of the angle between them when they are tail to tail. So we know for a fact that these magnitudes cannot be any bigger than 1 because both the j hat and the I hat and the, or I should say all of the hat vectors have magnitudes of 1. I hat, j hat, and k hat all have magnitudes of 1. And then the sine is either going to be 0 or 90 degrees. And then we'll just use the right-hand rule to dictate which direction it goes in. So with that in mind, now all I have to do is go through and realize, wait a second, whenever I have two vectors that are parallel, then theta equals 90 degrees. So I hat cross I hat equals j hat cross j hat equals k hat cross k hat. All of those have to equal 0 because it's 1 times the sine of 0, and the sine of 0 is 0. So when we do that, we can automatically assume that this is 0. And again, I'll say theta equals 0 degrees. We also say j hat cross j hat is 0. Again, because theta equals 0 degrees. And k hat cross k hat is 0, again, because theta equals 0 degrees. So now I can do 1 times negative 48.1. So negative 48, oops, I should probably put it back in green. So negative 48.1 Newton meters. Remember that actually did have 3 sig figs, and one had newtons and the other one had units of meters. But now we have I hat cross j hat, which is uh, I hat cross j hat is basically the first two of the triple. The triple is supposed to be X, Y, Z in that order. So if you do I hat cross j hat, you get k hat. So this one just turns out to be positive k hat. The next term is 1 times negative 9.63. So this is going to be negative 9.63 Newton meters. That took care of this one, and now we're taking care of this one right here. Now in this case, it's I hat cross J hat. So if you imagine coordinate system drawn properly in three dimensions, for instance, as a right-handed coordinate system as well, we could, for instance, realize that this is the actual this is the actual orientation of the XYZ coordinate system. So there's X, there's Y, there's Z, and we can use our right hand rule to see what I hat cross K hat is. So I put my right index finger in the direction of the first vector, which in this case you can see is I hat cross K hat. So I'm going to put it in the Z direction, which is coming out of the page. And then I've got to adjust my hand till my finger can point in the same direction as the second vector, which in this case is the K hat. So I have to turn it like this. So now you see my index finger is pointing out of the page. My middle finger, which represents the K hat direction, is pointing straight up. And then my thumb is the answer to the cross product, and it points to the left, which is the negative J hat direction. So I hat cross K hat gives me negative J hat. So I'll put in negative J hat. Oops, got the wrong color. That took care of the second term. Now the third term, the first term of course was 0, but the third term is 2 times 9.63. That gives me 19.26. So I'm going to say plus 19.26, carrying one extra sig fig, Newton meters. Now that one gives me J hat cross I hat. And J hat cross I hat would be, again, looking at this corner, this coordinate system in the bottom left of the page. J hat is this guy, and I hat is this guy. So if I stuck my first vector, which is supposed to be the J hat, if I point it in the positive Y direction, which is to my right, and then I put my second one in the positive X direction, which means out of the page, then my thumb is now pointing down. My right hand thumb is pointing down. That means it's the negative K hat is the result. So now I'm going to write down negative K hat for that. I should probably, just to make it nice and easy so we can track back, this is supposed to be J hat cross I hat. And the other one, the last one was supposed to be I hat cross K hat. And the other one was I hat cross J hat, like that. So that's really what I'm doing here. Now I'm going to add another term. I'm going to put it right here on this row. So we've now done, by the way, uh, the first term, which was 0, the second term, third term, fourth term. Now we got to do the fifth term, which is 0, but the sixth term is not 0. It's 2 times negative 9.63. So 2 times negative 9.63 is negative 19.26 Newton meters. And of course, the negative 19.26 is being multiplied by J hat cross K hat. And J hat, if we make our right finger, our right index finger in the direction of J hat, and then we write our middle finger in the direction of Z, which is up, we can see that my right thumb is now pointing out of the page, which is the positive uh, I hat. So this one's just going to be I hat. So that was, as I said just now, was J hat cross K hat. Now we've got to bring in another term. I'm going to jump to this guy right here, 4 times 9.63. 4 times 9.63 is 38.52. So I'm going to write positive 38.52 Newton meters. That 2 is an extra digit, as was the 6 in the last two. And now what we're getting is we're looking at k hat cross I hat. So k hat cross I hat, I'll write it down here at the bottom. K hat cross I hat means stick your index finger in the upward direction, which is the k hat direction, and stick your middle finger in the I hat direction, which means coming out of the board. And you see that when you do that, your thumb points to the right, and the right is the positive j hat direction. So this will actually equal positive j hat. So I'll just write j hat for this one. Now I also have to do 4 times negative 48.1, and that gives me 192.4. So I'm going to say plus, again, this is negative, so it'd be negative 192.4 Newton meters. And in this case, I'm actually multiplying k hat cross j hat. So this is k hat cross j hat for this one. And k hat cross j hat, double checking. And also, let me mark off the one I just did, which should be this guy. Uh, K hat cross J hat. You stick your right index finger in the upward direction because that's the K hat direction. And then you're crossing it with J, which means your right middle finger needs to point to the right. And what you see is my thumb is now pointing into the page, which is the negative I hat direction. So I'm going to write this as negative I hat in green, of course. And that's basically it. So now what we want to do is combine like terms, and I can say then that the torque is equal to, first off, let's take the I hat term. So here's an I hat term, and here's an I hat term. So what I get is negative 192.4, and I'm adding to it, negative times negative is a positive. So negative times a negative gives us a positive 192.4, and then I am subtracting from it 19.26, and that is because of this negative 19.26 and this negative make positive. So 192.4 minus 19.26 is equal to 173.14. Now we've got obviously two extra sig figs, and this is Newton meters, and in this case it's in the I hat direction. We also now can do the j hat ones. So the j hat ones are going to be this guy. Excuse me, I should write it in red so it stands out a little bit. That negative j hat and this positive j hat. So this negative j hat is negative of a negative. So that should be a positive, so it'd be 9.63. And then that is added to 38.52. And that gives me 48.15. 0.15 Newton meters in the j hat direction. So that should be right. I want to double check that negative sign. I got the 9.63 from I hat cross j hat, and I hat, yeah, that is right. Uh, that is the I hat cross k hat. Yeah, that was 9. Okay, so that works. Now all I've got to do is get the last two terms, which are the k terms, and this one gives me a negative 19.26 and another negative 48.1. So they're both the same sign, so they're really just being added in this case. Uh, they're both negative, so 48.1 negative plus 19.26 negative gives me negative 67.36 Newton meters K hat. And in that case, we were actually adding the uh, 19.26, which was only good to one decimal place, and the 38.52, which is also only good to one decimal place. So that means the 6 is not significant. When I got the 48.15 that I previously did, that was a result of the 9.63, which had two decimal places that were significant, and the other J hat term was 38.52 that only had one. So we have to also recognize that this 5 is not a significant digit. So that should be the actual cross product